Hi friends, and welcome to a new session with Score with me, and this is IB here to assist you today in permutation and combination. Don't run listening to permutation and combination. This is not as difficult as people say it is. So let's understand from the basics, and anyone who has even forgotten or does not know the basics of permutation and combination can join and study, and we'll score the best from permutation and combination. So come, let's score with me. Permutation and combination seems to be a very confusing topic for most of the aspirants, and that is the main reason why students leave this particular topic from exam point of view. Because always the thing that comes into our mind when we read the topic itself is we'll be getting confused on seeing the question if we need to apply permutation or combination in particular questions. So by the end of today's session, we'll have our doubts clarified, we'll have the concepts very clear, and we'll no longer be having this confusion if permutation has to be applied to questions or combination has to be applied. So please be patient and watch till the end, and by that time all your confusions will get clear, your concepts will be laid strong. So come, let's get started. Permutation and combination is only a game of counting. We need to understand where and how and by what way we need to apply concepts on each and every question. So we need to start from the very basics of principle of counting. Principle of counting is nothing but how things are taken into account and when they have to be taken into account. Let us begin with principle of counting, and here we are going to understand the concept of when to use and where to use or. So let us take the example of 3 pens and 2 markers. So with this example, we are going to get this concept clear. So we need to select or pick. At the first state, let us select or pick any one item from among 3 markers or 2 pens. So how are we going to do that? So we have got P1, P2 and P3. So we have got 3 items, P1, P2 and P3. In the same way, we have got 2 markers as well, marker 1 or marker 2. Now understand the concept that we have to select only one item from among these 3. So from among these 3, we need to select only one. That can be a P1, that can be a P2 or P3. So we can select from among these 3 in 3 ways, either pen 1 or pen 2 or pen 3. Now from these 2 markers also the same concept, we can either select marker 1 or marker 2. So this again in 2 ways. Now that can be a pen or a marker. So again from among pen or markers, that again is an or. So 3 or 2. So in one way we are going to have a selection from among 3 pens or 3 markers. So that is why we have a sign plus. So this gets added and we come to a conclusion that in 5 ways we can select a pen or a marker. So in the second case, we are here to select a pen and a marker, one pen and a marker. In the previous case, we had to select only one item from among the entire pens and markers. So here we can select pen in 3 ways, P1, P2, P3, and remember with each pen I need to select a marker also. So with pen 1 I can select either marker 1 or marker 2. The same from pen 2, if I select, I can select either first marker or the second marker. With pen 3 also I can select marker 1 or marker 2. So in this way, with each pen I can select either marker 1 or marker 2. So if I were to say from these pen 3 pens, I can select them in 3 ways, and from the markers I can select them in 2 ways. So a pen and a marker, that gives me a multiplication equivalent, and 3 into 2 gives me 6 ways. If further again you need things to be clarified, we can say that this is one case P1 M1, this is second case P1 M2, either P1 M1 or P2 M2. So P1 M2. So here this I can get them in how many ways? I can get them in 2 ways. 2 ways. So same is either P2 M1 or P2M2, this again in 2 ways. So on the whole, this is how we come here for 6 ways, and that is the reason why permutation and combination, we need to understand if and comes or comes, when to apply multiplication and when to apply addition. So hope that concept got clear. So and will give you an multiplication operation. Getting into the concept of permutation and combination, let us understand how they are different. These two are just ways of counting or arranging or selection. How people are selected, arranged from among a group of bigger people. With the help of a cricket team, we'll understand the concept. So say for example, in our front, our intention is to select members of a cricket team. So first step is to select a group of 15 people, isn't it? And there in this selection, we do not have any particular order. We just need 15 people for our cricket team. These 15 people form a group of players. This selection where no order is given importance is combination. So in combination, we just perform the operation of selection. We do not have any order. Order is not given any importance. So without importance of an order, we are just selecting group of people. That is combination. Now coming to permutation. After the selection has been done, we have 15 people with us. They are our group members or cricket team members. All these 15 don't go to the ground, isn't it? We have particular number. Say for example, 11 or 10 people playing in the ground. And when batting comes, they are again ordered. Like first one has to go for batting, and then the second, and then the third. So their importance is given to order or sequence. So when order is given importance, that is arrangement. So what is permutation? Permutation is arrangement. And how do we arrange? We arrange only when we have a particular order. So in this cricket team, we have the particular order in which they are going to bat. That is permutation. And when team was selected, there was no order or sequence. We just needed a group of people. So we were selecting 15 from among the crowd. That group comes under selection. That is combination. So selecting without any preferences or order is combination. Whereas in permutation, we have a proper arrangement. We have a sequence. After knowing what is permutation and combination, we also need to know their formulas. So see here formulas, NPR is n factorial by n minus r factorial, NCR is n factorial by r factorial into n minus r factorial. And after knowing the formulas, the first thing that we know is what is a factorial. So next, let's see what a factorial is. A factorial is representation of a number in terms of its multiples, and that goes in decreasing order. So n factorial is n into n minus 1 into n minus 2 up to we reach till 1. So 3 into 2 into 1. That is n factorial. For an example, let us see what is 52 factorial. It is starting from 52 till we multiply up to 1. So starting from 52 into 51 into 50, and that goes till we become till 1. If we need to know what is 4 factorial, that is 4 into 3 into 2. So that is 24. That is how factorial is calculated. For simplification process, we need to know the factorial of at least up to 6. So 0 factorial is always 1. Have that in mind. This is very important. 0 factorial is 1. 1 factorial is 1. 2 factorial is 2 into 1. That is 1. Sorry, 2 into 1, that is 2. 3 factorial is 3 into 2, that is 6. 4 factorial is 6 into 4, that is 24. 5 factorial is, you can write it as even 5 into 4 factorial. So 5 factorial is 120. 6 factorial is 6 into 120, that will give you 720. So at least have these many factorials in your mind. Now having known the formulae, let us get into the application part. So see NPR, we have the formulae, so let us apply that. Take for example, we have 10p3. So our formula says n factorial, that is 10 factorial and n minus r. N is 10 here, r is 3 here. So that is 10 minus 3, 7 factorial, and on simplification we have 7 factorial in the denominator. So we go on decreasing this till we go for 7 factorial, so that these two get cancelled, and so our answer is 9 8s are 72, 720. So here 10 into 9 into 8 is being done. Again, let's take 15C4. 15C4, n is 15, 4 is r. So 15 factorial, that is n factorial, and denominator n minus r, 15 minus 4, so it is 11 factorial. So in the numerator, we go on decreasing till we reach 11 factorial, so that we can cancel out them in the denominator. So see here, again we have 15 into 14 into 13 into 12 as our answer. From this, we need to understand that whenever a number is given for, sorry, this was permutation, so 15P4, not C4. Rather than applying the formula, we can directly write this starting from 10. In the R portion, we have 3. So in the decreasing order, if we write the 3 terms, 10 into 9 into 8, we'll get the answer without going for the need for calculation and simplification. Again, 15P3. If we have this, we need to, starting from 15, we need to write in 3 places in the decreasing order. So we'll get 15 into 14 into 13. That will be enough. Even if we go for the formula, again we'll have one more term and we need to cancel them out. There's nothing more in that. So we can avoid that step, and whenever in permutation comes, remember, take the n, start writing in the decreasing order. How many terms? The number of terms that occurs in the R. If it is like 100P5, what does that mean? Starting from 100, we need to write 5 terms in the decreasing order. So 100 into 99 into 98 into 97 into 96 will be our answer. Remember, number of terms and starting from the n term in the decreasing order will give you answer without going for any simplification process. For understanding the concept of permutation, we have taken an example here. So we need to find the number of ways in which 3 friends A, B and C can be seated in 2 chairs. So there are only 2 chairs, 3 friends. We just need to know the number of ways in which they need to be arranged. So it is the process of arrangement. So understand, if we are taking first A and B, A can be seated in the first chair, B in the second chair. Also, the same A and B can be seated in this way also. A and B here is, B is sitting in the first chair, A is sitting in the second chair. Since they are arrangement, these two give us 2 different forms or 2 different ways. In combination, if we have 2 chairs and if we have 2 people, they can be seated in any way, and that is left to their freedom. Both the ways are same in combination. Understand? AB and BA, we have 2 chairs, 2 people. In any ways they can sit there, they have got the freedom of arrangement because only selection is done in combination. So in combination, AB and BA will be same. In permutation, they will be different. Always have this thing in mind. Here, AB, BA, we have taken. Next we can take CB or BC. Next we can take CA or AC. So in this way, they can be arranged in 6 ways. These 3 friends can be arranged, made to sit in 2 chairs in 6 ways. If we go for the formula, we have got 3 friends, we have got 2 chairs, and we know the formula is 3 factorial by 3 minus 1, that is 1 factorial. We know 3 factorial is 6, so we got the answer here as 6. After being clear with the permutation part, let me say the formula and the explanation. So number of ways of arranging n elements taking r at a time is permutation. Number of ways of selecting n items taking r at a time is combination. So here n has to be the total group of people or group of elements from which we are selecting or arranging. So always the bigger element will come in the upper part, and the smaller one, the number of things that we need to take, as we took 3 friends and 2 chairs. So we had to select from among 3 people 2 chairs they had to be seated in. So that is why that 2 came here, and the 3 chairs, total 3 friends were in the n part of it. So that is all about the formula and the definition. Once we have the concept clear, the next thing that we need to know from exam point of view is what sort of questions can come from permutation part. So these many type of questions can come from permutation part. One is the number of ways in which certain words can be arranged. So that is words can be arranged, and next is we will be given few digits like 1, 2, 3, 4, 5 and how many ways can they be arranged. So that is from permutation part, the number of ways in which questions come. Repeated letters and non-repeated letters. So that is if we have the word max, how many ways can we arrange them with repeated letters and non-repeated letters. So if we have max, we can arrange them in, we have got 5 places and all the 5 letters are different. So we can arrange them in 5 factorial ways. If we had repeated letters, say for example, we had a word like S. This can be arranged in 3 factorial ways because we have got 3 words, 3 letters in the word, and as S is coming twice, so repeated letters, so we have to divide that. So those many type of questions can come here. Repetition is allowed. Now here we did without a repetition. If repetition is allowed, again that is going to be different. Always together, never together. So that is again ways of arranging odd and even places. So each one is given a place, and if we are given restriction on how each word can be placed, that again will give us different sort of question. And when we come to numbers with zeros, the question differs because there is a specific condition that has to be taken for solving such questions. So these many types of questions can be coming from permutation part, and this we will be seeing in the next video part. So here we will make our concepts clear. Type of questions we will be discussing in the coming sessions. Now let's understand the concept of combination. Just as we did for permutation, let us take 10C3. So here we have n factorial by r is 3 by n minus r factorial. So it is 7 factorial. If we go for simplifying, 10 into 9 into 8 into 7 factorial. This again 7 factorial. Why did we do? Because we had 7 factorial in the denominator. So we came till 7 factorial to cancel this out. And we got 3 factorial. So what did we get here? Have that in mind. Just as the previous form, we have got a form in combination also. Again, let us see here 15C4. So that is n factorial combination. N factorial by r factorial is 4 factorial. N minus r is 11 factorial. Again, if we write up to 11 factorial in the numerator, we have 15 into 14 into 13 into 12 into 11 factorial. And by 11 factorial into 4 factorial, this gets cancelled. We will be left with 15 into 14 into 13 into 12 by 4 factorial. Just like we did in permutation, in combination, 10C3 can be written directly as starting from 10, 3 terms in decreasing order, 10 into 9 into 8 by, here in the denominator one more thing gets added, and that is r factorial. 3 factorial gets added. See, from here we brought this form. If that were in permutation, 10p3 was simply 10 into 9 into 8. 3 factorial did not come in the denominator because in the formula for npr, we do not have this r factorial in the denominator. We just have n minus r factorial. That was the reason we did not have r factorial in the denominator. Here, let us see for this thing. 15C4 is nothing but 15 is 100C5. We need to go from 100 5 terms in the decreasing order by 5 factorial. So see how easy it is. So that is how we can make our simplifications easier. And in combination, when we see things, that questions that come, that is involving selection part of it. So selection or a group of people. Say for example, questions that come are generalized in the form as selecting a group of 3 men and 2 women from a group of 10 women and 15 men. So from a big group, a small group is selected. Here order cannot be given an importance. If we need to select any 2 men, they can be stronger, they can be taller, they can be fairer, so they can be any way. Order is not important, and whenever order is not given importance, that comes under selection, and that goes for combination part questions. Okay, next is the ways in which we can form necklace, beads in the necklace, because necklace can be formed in any way. Number of ways in which lines can be formed from given points, number of which polygons can be formed from the given number of lines. So all these sort of questions come for selection process, and that comes under combination. We need to know in combination is a formula that NCR is equal to NCN minus R. How are we going to relate this? 10C7. 10C7, see the N and the R, they are too long. That is why 10C7 can be also same written as 10C3, N minus R, 10 minus 7. Same thing, it is applicable in questions when it comes in the form like 51C49 is equal to 51C 51 minus 49, that is 2. This can be done in 51 into 50 by 2 factorial, isn't it? So easy. Again, see 100 C97, that is same as 100 C3, 100 minus 97. Aptitude remains incomplete if we don't conclude our sessions with questions, isn't it? So for getting that clear, we have taken 2 questions here, and these 2 are number of ways to select, and that is where we understand it comes under combination. Remember, this word is the particular word for helping us to understand if it comes under permutation or combination. That permutation was simple arrangement. Here we are selecting, and see, from a group of 7 boys we need to select 5 boys. So no order. Boys can be white or black, fair or dark, tall or short, irrespective of their differences. No order is given, so that is selection and that is combination. Here again, ways to select a team. So again, selecting a team, we do not give any preferences or priority, no order, so that is combination. So here, what is the number of ways to select 5 boys from 7? So 7, which is larger, that comes in the NCR part of it. So 7 boys, so 7C5, and we remember whenever the numbers were too large, we are going to see NCR is equal to NCN minus R. This thing we have to keep in mind. NCR is equal to NCN minus R. This has to be kept in mind. So we are applying that here. NC, 7 minus 2 is 5. 7 into 6 by 2 factorial. Simply. So that answer is 7 into 3, so 21. Bingo! So easy. Next, the next one. Number of ways to select 5 members having 3 boys and 2 girls from a big crowd of 7 boys and 7 girls. Here, and. So and means it is multiplication. And or was addition. Hope you remember that, and that has to be given importance here. We need to know those small things. So remember, or is addition and is multiplication. So this and means multiplication. So here from 7 girls we need 2 girls from 7 girls. So 7C2, that is the number of ways of arranging girls. Now boys is 7C, we need 3 boys from 7 boys. So 7C3, and 7 girls and 7 boys, not or. So since it is and, we are having a multiplication. So 7C2 is 7 into 6 by 2 factorial into 7 into 6 into 5 by 3 factorial as came from our formulas. So this is 3 factorial is 6, so this gets cancelled here. So our answer is 21 into 37, 735 is the answer. With this, the basics class of permutation and combination is getting over. Hope you had your foundations laid strong, and if you have got any doubts or clarifications, please do write to us or to comment in the comment section. So till we meet in the next video with more questions on permutation and combination, have a nice time. Thank you.